a few breaths before you get going.
All right. Welcome everybody to Geologic Maps and Cross Sections in QGIS. I am not sure where everybody is, but I'm going to say good morning because I'm in Colorado. Welcome to this workshop. The first thing that we're going to do is talk about geology for a while. And then we're going to work with geologic maps in QGIS. And then at the very end, if we have some time, we'll go into Inkscape and see what it's like to start building this cross-section in that vector graphic software. So that's our outline for the workshop, and we'll take a little bit of a break between those three different sections. So that's the overview. The first thing I want to do is introduce myself and a little bit about why I wanted to do this workshop. I am the Geospatial Services Specialist at Auraria Library, but my background is actually in hydrology and geochemistry. So I got my degree in the Geological Sciences Department at CU Boulder. I have a student that I was working with recently who showed me a cross-section that he made in QGIS, and his name is Miles Husky, and I was really taken by this, and I thought, oh, I have a geology background, I should play around with this and maybe share it at a conference in a workshop style. So that's sort of the story behind it. Unfortunately, Miles was not able to join in helping me with this workshop because they are up in Alaska right now, which incidentally is where his cross-section came from. But in his stead, my friend and colleague Patrick McGranahan is staffing the chat. So if you have any questions, he's been through this workshop flow with me and he's going to try and answer some of them in there, as well as the wonderful conference organizers that are paying attention to the chat on YouTube. So let's go ahead and get started. I have this document that has a lot of what we're going to be talking about, so you can come back and reference it at any time. They have it linked in the QGIS conference schedule, so if you don't know exactly where this is and you want to have it on your own computer, you can go and get the link from there. This is just a GitHub Markdown document that I've made. So what we're going to be using today for software, QGIS, obviously, and we'll also touch into Inkscape a little bit. There is data for this tutorial. If you haven't retrieved it already, you can go to this link, this Dropbox page. And when you get there, you will see just different folders of data, geologic maps, and geologic symbology. And I just want to make sure that everybody can see that. So if people could give a thumbs up in their little reactions. I want to make sure I'm sharing my screen and not just, okay, perfect. So up in this upper corner, there's a download button. If you click on that, you will get all of this information brought down into your computer. And then it'll be in your downloads folder, but you might want to move it to wherever you keep your data. You'll want to expand it, so you'll be seeing just this zip folder, QGIS NA 2020. But inside it will be all of these three folders up here. And I point this out because if you open up the geologic symbology one, there's one more folder in there that needs to be unzipped as well. So that's the data, and you can work on getting that down onto your computer while I go ahead and go back to talking about geology. because in order to understand what we're doing today, we need to have a little bit of knowledge about rocks. And so what we're going to talk about is different kinds of rocks and the rock cycle a little bit. There's three main different kinds of rocks: igneous, sedimentary, and metamorphic. And I'll talk about what those are. We're mostly going to be working with sedimentary rocks today because they're the easiest to interpret when you're looking at data in the field and then trying to map that in a cross section. We'll take a quick look at the time scale just to know kind of this mind-boggling scale that this is working on. And then we're going to talk about what structural geologists do when they go out in the field and they get measurements and try to look at rocks that they're walking across to see what kind of rocks they are, whether it's that igneous, sedimentary, metamorphic, and then take measurements about what angles they're likely lying at based on what the mineral structures look like, or if there are bed exposures. And there's some photographs that are later on that you'll be able to look at and get a sense of that. And then, like I said, we'll be working in QGIS to do this mapping and then pull out information from our GIS into Inkscape to build a cross section. So geology is really complicated. So this is just a warning. This is for people that want to kind of get a better sense of, if you're hiking in a park and you're seeing some rocks and you're just like, oh, I'd love to play with that in a map. This is not going to make you a professional geologic mapper, but if you're a student, it'll give you a good introduction to it. And why do we care about this if we're not actually a geologist? Well, it's interesting to think about the applications of structural geology underground when you're thinking about groundwater flow and how those formations affect what's moving around down there, or whether there's some oil shells, or how would you extract that if that's something that you're working for your business. So that's why geology is important. A lot of structural geologists have done a really good job of mapping the world, but it's a very time-consuming and difficult process. And that kind of speaks to data that we'll be able to find as well. So geology, rocks and time. I have just written up a little simplistic summary of the rock cycle here, but the Earth is a dynamic system. And much in the way that we can see water evaporate from the oceans, go up in the air and drop, rock things are the same way. They just work on a much longer time cycle. So if you think about the center of the Earth and the molten core, and down there in the bottom where things are really warm and hot and you have magma, that can come up closer to the surface, cool, whether it's near surface or on the top. It can be eroded, carried around as sediment, put down in layers, and then buried again or compressed, and then turned back into rock based on pressure and temperature areas that it can be in. So those are the two main types that we think about a lot. There's igneous rocks, and those are rocks that are formed directly from a lava or a magma. And they have a crystalline structure like this granite down here. So when that magma cools, you'll see a very nice mineral structure when you're looking at the rock. If you can't see it, it might be because it cooled really fast, like lava in Hawaii, so that the mineral structures is very fine grained. So when these things get eroded and laid down in sediment, then we have sedimentary rocks. An example of that is sandstone. And a lot of these they're put down in flat layers just because gravity works that way. If you have sediment and you dump it somewhere, it will spread out. But then that flat layer might get turned later based on tectonic forces that are happening in the Earth's crust. So there's a whole lot of different kinds of sedimentary rocks, but sandstone is one. And it often talks about what does the grain that's put and cemented together look like? And the third type is metamorphic rock. And there are all different kinds of ways that this can show up, but basically, if a sedimentary rock gets melted or pressurized or chemically changed, but doesn't completely turn back into molten magma, and then it forms again, then you'll get a metamorphic rocks that gets all sorts of interesting shapes in it. So that's a quick overview of the 3 basic rock types. And then that rock cycle about uplift, erosion, deposition, and then burial that's turning these things back into rock again is that rock cycle. It just works on this really, really, really long time scale that's pretty mind-blowing. So we'll look at some quaternary things today. Those are very recent. So if I say quaternary deposits, those are things that are less than 1 million years old. So MA is million years ago. That's a abbreviation for geologic time. And why this is a bit important is these different time periods are used to label different kinds of rock structures that we'll see on our maps. So just a quick look at that. So part 2, structures. What happens when we're looking at this stuff in the field, and how do we try to determine what the structures are and then represent it on a map? So you'll hear me using terms like dip and strike. If I have a bunch of sedimentary beds that do get tilted for some reason, they have a dip to them or they're angled down. And the strike is something that has to do with that angle of rotation. So if my beds dip directly to the east, then my strike is going to be pointing directly north. It's a perpendicular direction to where the dip goes down. So that's what the strike is. And that's important because we'll be using that in our symbology for the map. So there's some other structures here that you can go ahead and look at, talking about faults a little bit, what they do to different sedimentary beds and how that looks on surface exposure. And we'll be using that kind of knowledge when we interpret our map to try and build the cross section. So there are a bunch of different kinds of symbologies that are used for this. We're just going to use a very minimal set of it today, but there are some standards that you can look here. And so I have left just a bunch of words here for you to kind of dive back into, but we need to get into our area of interest and start working on this project. So I am in Colorado, and there is a set of iconic mountains called the Flatirons, and this is the region where we're going to map. We're going to be a little bit south of this. So these are sedimentary rocks that have gotten tilted up, and then the erosion away from them has exposed them. And you'll notice that at the very top of this tutorial, there was a quick snippet of a geologic map. And I found that and a bunch of other ones from this National Geologic Map database. The particular one that I want to show you just to see what a geologic map is this one. It is by Wells, and it was done in 1967. And all of these beautiful colors here represent different kinds of rocks that we can see on the surface. And if you look in closely, the colors represent a certain kind of rock, and they have descriptions about what these formations are and what the rock types are. And where we're going to be is right up here in this area. And these light pink things up here are the Flatirons, that picture that I just showed you. So this is going to be the area that we're working in. If you didn't download these maps, that's fine. You don't need to load them into your GIS software if you have a slow computer, but they're good for reference just to see that. All right, so let's go ahead and open up QGIS. And if you want to follow along in the tutorial, you can. And I'm just gonna open up my software and have my tutorial over here on the side so I can see what you might be looking at on your own too. All right, so when you first open up QGIS, and I'm going to turn my video off now just so that you can see my whole screen very well. When you first open this up, you will see recent projects that you might have been working on, or if you've never opened up QGIS before, these won't be here, but then you can just select new empty projects. So all of the data that I have provided for this tutorial is in a certain projection, and you'll find with geologic data that the projections are kind of old and wonky because it takes so much work to put all of this stuff together. A lot of it is very historic data. So the first thing that I want all of us to do is change our CRS from this default 4326 down here in the corner to the same projection that all of our data is in. So I'm going to go up to my project and go to project properties. And when I click on that, I'm actually looking at information for this whole project. I'm not looking at specific data layers. And right now, I already have the coordinate reference system menu highlighted. But if you have something else over here, make sure you click on CRS. And then what we're going to do is look for this 26913, because that's the coordinate reference system that all of the data that we're using today is in. I was able to click on it because I've already had it in here, but if you just go up to here and type in.
Hey, Diane, if I
Yes.
can step in for a second.
Yeah.
We only see your Chrome screen right now.
Oh, so I'm not sharing my screen. Okay, hold on, thank you. I must have just been sharing Chrome instead of screen. How's that?
Looks good.
Thank you. I thought I always share my app, so sharing my screen's a different thing. Let me go ahead and back out of that. So this is QGIS. I've already clicked on new project. You might have seen some other things in this space. But if you go up to the project menu and go to properties, then this is where I was talking about making sure that the coordinate reference system menu is highlighted right over here in the corner. And the coordinate reference system that all of our data is in today is this EPSG 26913. If you don't see that easily, and it's very likely you don't, just go up here, and if you type in 26913, it will limit it to the ones that you can find. So go ahead and select that and click OK. And what this does is it puts your whole project in that coordinate reference system. So the next thing we want to do is load our data and explore it. So if I go over here to the Open Data Source Manager button, and I open that, then I can see a way to load all sorts of different kinds of data. If you don't know some of the difference between these, we're just going to be working with vector and raster data. And the first workshop from this conference last Friday was a really good introduction to that. But most data today is vector except for one file. So I'm going to go ahead and leave it on vector. And here I'm going to navigate to, let's see. my workshop folder where I have this data. And I can pick all of these at once. All of the GeoJSONs are a certain kind of vector data that we can load. You might also find shape files, which are a lot more messy and have a lot more parts. So I opted to use GeoJSONs for simplicity today. So I can select all of these and click open. And now they're all loaded in here, but they're not on my map yet. And I need to click add. So when I do that, all of it drops into my layers menu over here. And some of them might be a little bit hard to see because they're being blocked by other layers. So I can click on these and move them around and make sure that everything that I want is there and I can see it and understand it. So there is another layer that I want to add in, and I'm going to go back up to my Open Data Manager, and this time click on raster because this is a digital elevation model that we're going to pull in, and it's going to help us build our profile. Now, when I click on the three little dots, it's going to go back to that same folder that I was in. So that's nice. It remembers things for me. I'm going to select this TIFF file. And again, I have to click add and then close. And so it came in on the top. And so it blocked our view of everything else, but that's fine. So this, for people that haven't used digital elevation models before, this is just a pixel layer that is showing us high elevations with a white color and lower elevations with a dark color. So we'll go ahead and look in a different way of symbolizing this with contours in a minute. But the next thing I want to do is turn off some of these layers and maybe just leave, let's leave our strike dip measurement layer on there. And now I want to talk about bringing plugins into our system so that we can have a little bit more functionality. So if I go up to the plugins menu up here and I go to manage and install plugins, there are two plugins that we would like to use today. One is just for fun and context, but we really want to get the qProf plugin. So when I click on that, it's going to connect to the world, and it's going to show me all of these plugins that I can load into my QGIS. So you'll want to search for Quick Map Services. That's this one right here. And this one's just a really nice way to have a base map be pulled into your system so that you can see what's going on, like where you actually are. And then the other one to load is our profile qProf. I don't know how the developer says that, but so this one is going to help us take that digital elevation information and create a profile out of it. So after you select these, you'll see an install plugin button down here. Go ahead and put both of those in. Mine are already in, so I don't have that option, but it's pretty quick. So I'm going to click close. Now, if I go back up to my plugins menu, and you should see this if you've installed it, you'll see that new qProf plugin show up right here. But the Quick Map Services one isn't there. It's actually over here under Web, because it's something that connects out and pulls in services to your GIS. So I'm going to go to Quick Map Services, and I'm going to load an OSM base map into my QGIS just so that I've got a better orientation in space about where I'm working. All right, so because it's a base map, it does load at the bottom layer, which is kind of nice. And we can see that here we are at the National Center for Atmospheric Research near Boulder, Colorado. And if I also want to load in my geologic maps for reference, that can be another raster layer that's loaded in here. So let me show you a different way of loading data. Instead of using this open data source manager, I can also go into my browser window here and open up a file. This is an external hard drive that I have connected. And I can go into my folder that has all of my data right here directly. So if I did this and I opened up this data folder, I could select all of it, all of the vector and raster at the same time and just drag it down into the layers. But right now I'm going to pull in the geologic maps just so that we can have them for reference. Now they are not reprojected, so I'm getting this warning. These are in the original projections that the map data was taken in, but I'm just going to use them for visual reference, so that's okay. I'm not too worried about that right now. So there are two different maps here. And if this is that warning from the transformation for the maps. Now there's this really great way to find information about your data layers over here. If I go to this data layer and I right click on it, at the very top it says zoom to layer. And this is great because if I get lost and I don't know where I am in the map, or I want to see what the extent of my data is, it's a really great way to visually check. So this is that map that I showed you from the database before. But there's this bigger map underneath here, and I'm going to zoom to that now. And it has a much larger extent. And so we're just working up here in this little corner. But the reason why I want to show this map, this Kellogg map, is that this is where our data came from. This is what I cropped the data from. So this is our source for our information. So I'm going to drag these down below here. That's the wrong one. Okay. That one. Yes. And that one. All right. So I'm going to go ahead and zoom back to our area of interest. You can see when I turn this on, you can see it's quite small compared to that whole area. So the next thing that I want to do is explore our data a little bit more before we take a small break and then go into doing some mapping and styling with this. It's always good after you turn on or load your layers to explore them a little bit. And a way to do that is, again, if I right click on these layers, I have this other menu. If it's vector data, you will see this open attribute table onto the side here. And if I click on that, I get a spreadsheet of information that is tied to those forms that we're seeing on the map. So these are the polygons or the outcrop exposures of all of the rocks that we see. And if I look at this one, so this one is called Boulder Creek granodiorite. This was a rock type field that Patrick added to this particular data layer so that we can match it to styling later on. So this is a part that's interesting about doing geologic symbolization is you'll see all of these different things in here, but then trying to decide what kind of rock type it is takes a little bit of decision making to match that up. So that's our attribute table behind the rock types. We also have a transect line here. This is just one line that I drew. This is going to be where we're going to take our cross section. Our strike and dip measurements, if we open that table, it has our dip angles. So these are numerical values that were measured out in the field. Some of them I took from a map. I've actually been here and done some measuring as well. And then these are our strike directions. The NCAR photo location, that's just fun. We'll talk about that later. There's not a lot there. And then our last layer to explore a little bit is this attribute table and of the faults. And the main thing to look at here is that there is an exposure column that talks about whether things are subsurface or whether they're below. So whether or not you can see that fault line on the surface. All right, so I am going to let us take a little break right now. And if you need to go visit the restroom, refill your coffee or something like that, go ahead and do that. And go ahead and explore those layers a little bit. Look at the attribute tables, and we will be back in about 5 minutes. So at 8:40 or so. All right. Welcome back. I am going to pause and see if anybody has any questions about the data after looking into it a little bit. One thing, just kind of going back after we've seen what the data files are, I think it's nice to go back to this structural part of the workflow and just kind of get us a sense of different kinds of structures that we have and what our data looks like compared to things that are happening on our map. So again, the strike and dip, we've seen those columns in our strike dip measurements file, and those are the angles of this dip going down and then the strike going across some bedding. And then the fault layer that we're going to be looking at, what that is it's going to be a trace on the surface of where that fault line is appearing on the surface. So if I'm looking at this normal fault where these two different blocks meet, that line that goes along where the edges are, that's the line that we're going to be seeing on our map. And sometimes these faults are thrust faults or a normal fault. Reverse fault is a thrust fault, and strike slip faults where they just move side to side. This is, the iconic kind of ways of people show this is if a road gets in the middle of an earthquake with one of these and they just show the double yellow line in the middle shifted or something like that. So that's kind of how these might look on the surface, is that the line of where the fault is actually happening. So those are the structures. And if we go back to our data, these are the different kinds of symbology that structural geologists use to represent them on the top. Now, as I mentioned in the document, there is a federal standard for the US about how to do this, and it's exceedingly complicated, and you can dive into those documents and find everything and more that you want for it. But today, when we do this, we are just going to be looking at a very small subset of these geologic symbols. So I'm just going to open this up real quick in my browser in QGIS and just show you that there are all these different markers that we're going to end up using in here that represent those structures. I did a small collection of the very, very simple ones, but the only one we're going to use today, honestly, is this one 6.02 bedding inclined. So there's just a whole collection of different ones of kinds of faults and anticlines and synclines. Just if you want to play a little bit further, this is kind of a nice little grouping of those. All right, so the next thing that we want to do is to go back to our main map area here. And we've looked at the vector data a little bit and kind of understood what's behind it. But now let's go back to our digital elevation model. And digital elevation models are things that can be used in a lot of different ways. And today we are going to use this information where each pixel has an elevation tied to it, give that information to the qProf plugin to be able to draw our profile. But right now, maybe our brain doesn't quite understand what we're looking at. And some people that are used to topographic maps might want to have some contour lines to look at. And also they can make our geologic map a little bit easier to interpret. So let's go ahead and make some contour lines for our project here. I'm going to go ahead and turn off my OpenStreetMap base, but I'll turn that back on later. And I'm also going to turn off my other, the geologic map that is our main reference for this, but we'll pull them back in and look and see where we are. All right, so here's our digital elevation model, and it's a raster file. So if I go back up to my raster menu up here, then I can find different tools that work specifically with raster data. And one of my favorite tools, which I love, if you go to extraction, there is a contour tool. So what this does is it goes in and it picks all of the pixels at a certain elevation and draws a line connecting them at that elevation and gives us, okay, this is all at 1,000 meters, and shows that as a topographic imagery on the map. So I'm going to take my input layer to be our USGS 3DEP digital elevation model from our area of interest. So that's what that long complicated file name is. The N40 and West 106 have to do with the last location of that. I'm going to leave the interval at 10 meters because it actually works out pretty well, but depending on your DEM or your area of interest, you might want to change that around a little bit. And right now I'm just going to leave it as saved to a temporary file. So it's just going to be something that's showing on my screen. But if I like how it looks and I want to save it as a vector file, I can do that later, or I can go ahead and just know that I want to do it now and put in a whole path name here. So I'm going to click run. And it's connecting all of those different pixels with the same elevation level. And it's done, but we didn't see anything happen over here because if you look over here, the contours layer came in underneath the DEM. So I'm just going to want to drag my DEM underneath that, and boom, there they are. QGIS does automatic color picking for us. So we got this yellowy kind of orange, but we can change that a little bit later if we'd like to. Or let's just go ahead and do it now. I'm going to turn off the DEM, and if I go over to this layer and I double click directly on that little color bar, it's going to bring up this menu directly in my Symbology tab. And I can go to this color bar, do a drop down and say, you know, actually I want these to be sort of a light gray eventually. So I'm just going to do that and click OK. We will come back to this Symbology tab a lot. So that's how you can do it very quickly. You can click directly on these vector colors and get right to your Symbology tab there. All right, so those are our contours. I'm going to turn them off. And I'm going to drag my DEM down here because we don't really need to see it much anymore. Now, the next thing that we're going to do is we're going to look at our strike dip measures and pull that inclined bedding symbol that I was talking about into our project and use that for showing what our things look like on the map. So if I turn on this geologic map that is not the source of our polygons, but is one that I'm pretty familiar with, and we look closely at it, I'm going to turn on my little zoom button up here, and I'm going to zoom into this map in a very particular spot. You'll see this geologic map has this T form on it with a 58 next to it. And what this is that strike dip symbol with 58 being the degrees of the dip. And the angle that this is pointing is showing what direction that dip of that particular bed is doing. So here's one that says this one's 57 degrees. Here's one up here. And I say up because I can tell I'm going up topo lines at 50 degrees. So I'm going to go back to our previous view and work just with our strike dip measures here. A little hard to see with that map on because that's pretty busy. And just to give that context again, if I turn on the OpenStreetMap database, you can see that there's a trail that goes back here behind NCAR. And this is where you can just go for a hike and see all of these formations in person. Okay, so how do we get that little T into our strike dip measures? If I right click on here and I go all the way down to properties, that's another way of pulling up this menu where I have all of these different things where I can click on, say, the source of this, and I can see what the projection of this particular data layer is. Yay, it matches our project data layer because I made that happen. But if I click on Symbology, this is where I can work with how my point of interest or my point feature class is represented on the map. So going to Simple Marker is going to give us a slightly different menu than what you see here. So here I can just change the color of my dot, or there's some preloaded ones that I can select. But I'm going to click on Simple Marker. And then you'll see it says symbol layer type here. Now, if we look over here, we know that we've got these SVG files that we want to load as our little symbols for the geologic structures. So I'm going to click on this drop-down menu and pick SVG marker. Now, to find this particular file, I need to drag this down or scroll down and go past. They have some SVG images that are already loaded, but here's that ubiquitous 3-dot go find your file button. I'm going to click on that. And in here, it's already going directly to my geology symbols space, but you can go ahead and search through and find the symbols that you want. And this is going to be the one that we want, the bedding inclined. So 6.02, and all of these numbers have to do with the USGS standards, and there's a whole bunch of these. But this is the one that we're going to want to load right now. So I will select that and click open. And oh, you know what? I was in the wrong folder. Let me make sure I'm in. Let's get it from this one. Bedding inclined. Okay, now we can't see it, right? It's there, but it is so small that it's barely recognizable. So I'm going to go back up, drag my toolbar up, and you'll notice that there's a spot here where you can change the size of it. So I recommend doing 7. The default was 2. Now all of a sudden it's appearing a little bit bigger, but you can change and adjust that depending on what your particular map looks like. So now when I click OK, all of those dots have turned into those strike dip symbols on the map, but they're all just pointing the same direction, and that doesn't really help us at all. We don't have any further information here. So the next thing I want to do is go back to that same interaction place where I'm on my SVG marker, and there's a field here called rotation, or an option here called rotation. And when you go to that, you can directly enter in a number. So if I just typed in 50, all of these would change 50 degrees, and it gives you a little preview up here. But that's not what we want to do. We actually have strike information that we want it to use. So I'm going to go over here and pick field type as the control for what my rotation is. And because I've already looked at my attribute table, I know that the azimuth field is the one that has that information in it. So when I click OK, now all of these are at funky little different angles because they are looking at that data in the field. Most of them are still pointing the same direction because of the nature of the area that we're at, but we'll understand that a little bit better as we dive into the rock formations. So the next thing is trying to turn on our labels for the dips so that we can see the numbers of how much those are actually dipping. So right now, I don't see my label toolbar up here. I managed to turn that off. So you can always go to View and go down to Toolbars and see all sorts of different kinds of toolbars that you can turn on. I'm going to turn on my label toolbar. And this is one way of getting to it. But you can also do that same thing where you go to Properties and open up this area and click on Labels instead of Symbology. So that's the great and also sometimes confusing thing about QGIS, is that you can get to functionalities different ways, but just keep poking around and you'll find things. So I am on my strike dip measures layer. And so when I am in here, I am working on that particular data. This looks blank because right at the very top, all it has is this no labels, but I want to change it to single labels. And now it's going to give me some options of how to do this with different kinds of fonts and placements and things like that, that I'll let you play with at some point. But right now, we just want to change our field for how it's labeled to dip. So we just get those numbers placed on our map. Actually, I am going to go and work on this placement a little bit, because sometimes when the dip is over the top of that strike symbol, it's a little confusing. So I'm going to click Offset from Point. And just because I know where some of these are kind of tight, I'm going to pick this box, but these are different placements that you can pick and move them around so that you can have them tuck into places where you can see that number associated with that file. Sorry, with that point. So this is our dip information, and this still isn't beautiful, but you get the idea. It associates that angle with that particular structure line. So if I go ahead and turn our geologic map back on, and let's turn on the other one where our data actually is coming from, you can see that that map has these in kind of bigger formation because we're really zoomed in on that map. But these are the different formations, and here are some of our measurements that we have. So this kind of grayish blue blob right here is dipping a little to the northeast at 57 degrees. And this is dipping at 58 degrees. So there's a whole line of sedimentary beds. So if we look at what these blobs are, these are all sedimentary rocks over here, and they're all kind of dipping up to the, or dipping down to the east. And just to give some background, if we look at, let's see, let me turn on Colorado, and I am going to zoom way out. So Colorado has a whole bunch of mountains over here, and it's really, really flat over here on this side where Denver is. And what the flat area was back in the Cretaceous time, there was a sea here, and all sorts of sedimentary deposits were put down on this side. And then the mountains that uplifted over here took all of these sedimentary beds along this old coastline right here and basically tilted them up, which is why when we zoom back into our area of interest here and we see all of these dramatic tilts of these beds, that's kind of the context of where we are for those. All right, I'm going to look at the chat really quick to see if there are any questions. Yeah, so there was a double unzip to get that structure symbols. So sorry about that. I hope that's gotten cleared up and people have been able to get that SVG file into their marker for the strike dip measurements. All right. So our next thing that I want to look at are our faults layer. So these I actually hand digitized directly off of this map right here, because if the faults that you're using don't line up directly with the polygon layers that you're looking at, then it doesn't make a lot of sense. So you'll notice when I turn the faults line on and off, it goes right along some boundaries of exposures of rocks. And that's a lot of how people see faults, because they'll look at those outcrops on the surface and they'll be like, oh, there's a big cut here. I wonder why. And if they do more investigation, a lot of times they'll find out there was actually a full old fault there. They might not be active anymore, which these are not, thankfully, because it goes right across town. then you can still map them out based on that information. So how we're going to do this, and I'm going to change my polygon color really quick to something a little bit lighter. So I selected directly on that, and it has a fill for the polygon right now. I'm just going to make it something light so that we can see a little bit better. So when we do the fault symbolization, we're going to cheat a little bit today. So I'm going to right click on my faults layer and go to properties. And we're in the symbology for a line layer. Now, you'll notice that I have some preloaded symbology here for lines for faults that have to do with planetary geology, but we're not really going to do that today. Today, we're just going to say, we're just going to use a dashed line and a solid black line to distinguish our two different categories for our faults, whether it's subsurface or surface. So I can turn them all black right now. And when I click OK, they just show up as black lines on the map, which gives us a good sense about the trace, but it doesn't really talk about whether they're subsurface or not. So if I go back in, instead of having a single symbol, I'm going to categorize my two different fault styles. So I'm going to go back into remembering my fields that I have behind it. And I know that my exposure field is the one that has the subsurface and surface classification for it. So after I do that, I'll hit classify. And then I get an automatic population of what looks like Easter egg colors up here. And there's always this default of all others. So if you have a null value in this field, it will show you if on the map if there's something that isn't classified at all, and it'll come up. And you can just turn that off if you don't want to have those shown. But this particular data set has full information. So all we need to do is just work with these two little pieces. So my surface one, that one I want to leave black, but I also want to make it a little bit thicker. You noticed it was a little bit hard to see. So I'm going to change it to 0.66 for the thickness. And that I did that just because that's what the official ones tend to be. Now I'm going to click directly on the subsurface one. And I'm just going to go down to this dashed black one that's here. And also have my check to make sure that my thickness for this one is also 0.66. And then I'm going to click OK. So now when I go back to my map, I have these fault traces that are going across, where I know that if I go out into the field, I'll be able to see that contact between the beds here, and here maybe it goes underneath something, and same with here. Now, why might it be going underneath something? Let's turn our polygon layer back on and find out some information about this. If I click on this I button up here and identify feature, and there's this blob of stuff right here that's covering up my fault traces in the north area. If I click on this, I need to make sure that I've got the correct layer highlighted, then it's going to show me that attribute information behind what that blob is. And it says it's a debris flow deposit. So this is something that's more recent. This is one of those quaternary structures that I was talking about that's just kind of plopped on top of everything. And so that's why our fault isn't exposed right there, because this sedimentary blob right here got dumped on top of it. So we have a bunch of green here, and it would be really nice to be able to have these things separated out so that instead of clicking on this with this identify tool, that we can go in here and represent all of these different rock types based on what the rocks are. So this is where geologic styling layers are really, really useful. I'm clicking too fast. Okay. So in the geologic symbology file, you will also find something that is called lithclass.qml. And what that stands for is lithology classification. Lith is a term that it means stone. It's from Greek, I believe. So anytime somebody says lithology, they're talking about stone types or rock types. So to add styling to this polygon layer, we're going to click on this layer again, go to properties. And here, before you saw me just change the color, we're on a simple fill right now. But down here at the bottom, there is a little style button that gives you the opportunity to load a style. And I've already provided you a file that will help us do this really quickly. So I'm going to click on load style, and that's for this layer because I'm operating on this layer right now. And again, there's some other kind of categories that you can go and pull things down. But for you, here's that ubiquitous 3-dot button. I'm going to click on that, and I'm going to go make sure I'm in the right folder this time. That looks like what yours should. If you open up your Geologic Symbology folder, there should be one here that's lithclass.qml. So I'm going to click on that, click open, and then load style, and voila, we have more information than we can handle. So there are so many different kinds of potential classifications for rocks. And this is where having your geology brain a little bit, again, is useful. But if you have gone to get a map from the National Geologic Database and you actually have a map like this, you can go into it and read the descriptions that are on the map. And so for here, for example, I can read that the Dakota group is a well-sorted fine to medium grained sandstone interlayered with, so it's a mess, right? It's got all sorts of things put in it. It's not just exactly a sandstone. Some things, like the Lion Sandstone, which is one of the formations that we're looking at, is very much just a well-sorted sandstone because it was actually deposited in a dune environment. So it was wind deposits. So think about the Great Sand Dunes if you're in Colorado, or think about the Sahara Desert. Just this is the kind of rock that was. But other things that were deposited from that seaway that I was talking about are a little bit more mucky. So they'll have clay or silt in it, or sometimes sandstone, depending on what the edge of that water was dropping down. So if I go back to what my classification file has in it, I can see all of these rock types that describe different things. So there's one, and this one cracks me up. It's like, if you want to just throw up your hands and just say, I don't know, it's a sedimentary rock, that's an option. But so what Patrick and I did is that we went into our attribute table and looked at all of our polygons and read what these rocks were. And then we matched these rock types by putting in that field. So now when I click OK, those colors are going to immediately drop onto my geologic map and symbolize what those formations are. Now, some of it's a little tricky. So if I go back to my information and I click on the fountain formation here, and this formation is the iconic formation that makes the Flatirons, that picture that I showed earlier. I have put it down as a coarse-grained mixed clastic rock because it's one of those mucky things that's made up of, it's part conglomerate, which means larger chunks of rock put down and cemented together. It's part sandstone. It's part arkose because arkose is a certain kind of chemical way of looking at a rock. And that's what is cementing all of these chunks together in the fountain formation that makes it really hard to erode, which is why we even have the Flatirons right now. So if I go back to our attribute table for this, and look at the rock types. These are ones that we filled in for you. So this is something that you would do. You would make this field and then look at, oh, okay, these are the names of those formations, and then write down, okay, that's a granodiorite. There's granodiorite in our rock type lith class styling. That's pretty easy, but a lot of them you have to make some decisions to try and figure out what should be the right symbology. And like I said, there's one that just says sedimentary rock, and if you need an out, that's what you can do. So our sedimentary rocks kind of end at this fault line right here. There's a little chunk of them up here, but everything over here is a big igneous blob of granodiorite with some other kinds of igneous rock mixed in. So that's good to know about when we think about building that cross section. Again, is checking out what these things are. Boulder Creek granodiorite, that is a very old early Proterozoic rock that all of these sedimentary rocks piled up on top of. All right, so we have something that looks like a geologic map here now. One thing that might be useful just for interpretation is to turn our contours on. And oh, you know what? I don't like that color. Let's make them a little bit, because it's almost the same color as the flat irons, if not exactly the same color. So I'm just going to drag this on my little triangle here. It's one way of adjusting things, and make that a little bit darker. Maybe too dark, but you get the idea. So that helps us give a sense of what the landscape is like. And maybe, you know, I might go back and make my contour intervals a little bit wider so I don't have so many of them in here on the flat irons, or make it lighter again. But another thing to do is to label what all of these rock outcrops are. So go back to my properties of that layer. And these are just the classes that I've attached on there. But to make more specific information available, I'm going to go to single labels. And a lot of times outcrop polygons come with a field called label. And if I click OK, all of these little abbreviations for those formations come up. And so then you can interpret those and go back to, you know, when you're looking at the map itself, you can see, okay, here's where KD is. Now I'm going to go over here and read what KD is underneath this part. So that's that symbology that we just brought into the map. And again, these are based on their ages. So a lot of the quaternary sediments that you'll see have this, start with this Q on top of it. So that's just to give you a sense. And here is all of our sedimentary layers kind of sticking out. And then here's a basin where a lot of rivers have eroded away the sediments, or a lot of sediments are just sitting on top of those. So I want to go back to the very top of this workflow and just show you that map, because there actually is a cross section that I put in. It comes on that map too, that kind of gives us an idea. This cross section is done a lot further south than the spot that we're working. But just to give you a sense of what we're kind of aiming towards, here are all of those igneous rocks in the background, and people can tell they're igneous or not by walking out into the field and taking a rock sample and seeing what it's actually like. And here are those sedimentary beds on the edge that have been turned up because all of the things on the west over here have pushed up and tilted them. But you'll notice if you look closely, there's like little blobs of that light sand or quaternary deposits sitting on top of this profile. So this person has chosen to just represent that as kind of like icing on the cake, just a layer of that information on the sands and debris flows and alluvium sitting on top. So if I go back, that's, if I'm looking down from the top like I'm a bird, I see a lot of that. But what's underneath is likely a lot more of these larger structures, older structures. All right, so I'm gonna pause a little bit and look at the chat and see if anybody has any questions. And the next thing we'll end up doing is going into our qProf plugin to get some cross sections. So I see there's a question about different color schemes for the USGS maps at different scales. And this, you know, there are different kinds of base standards that people use, but when you go in at smaller scales, there's a lot more different kinds of things that you might want to represent. And sometimes people use hatching patterns, and other times it's just slightly different changes in coloring, and it's just being able to differentiate things a little bit more. So if I were to zoom into this Dakota group exposure right here, and I'm looking at this, when I look at a picture of it and I'm on the ground, the more I zoom in, just like with any kind of geospatial data, I'm going to be getting more detail, and being able to differentiate that from different kinds of sandstone. They'll change different kinds of styling layers for it. I hope that kind of answers that question. Okay, so now I'm going to turn off my contours because they're a little bit, no, I'm going to keep them. I'm just going to make them a little bit less dark. And I need to make sure I'm on my Symbology tab. Just fade them out a little bit, but not so much that they're the same color as the fountain formation. Okay. That's there. That's a little better. I like that. You can kind of see them, but they're blended in there. That makes me happy. So now I'm going to turn on this transect layer, and I'm going to change it to a brighter color so that we can see it really easily. Maybe make it a little thicker too. So this is the line that I have pre-drawn. This is just one line that I drew that I thought would be a really good place to construct our cross section. But you can pick anywhere on this map. When we go into the qProf plugin, you'll see that there are different ways of being able to do this. So this one goes across from NCAR. So if we remember from our map of NCAR, here's where that building is, and that trail goes right back across here. And then these elevation miles, this is where the flat irons are, and we kind of have higher peaks. And then there's like this little weird dip, and then there's another set of high peaks over here. So our cross section is going to go right behind NCAR, right through there. So just as a reminder, our plugin is up here under the plugins, the qProf. When I go to it, it's going to open up this other window on the side, and my map is going to shrink a little bit, but I can give it a little bit more space if I hover between this window right here. Sorry, my computer's thinking too hard. I just want you to move over there. Great. And this is where that zoom to layer is going to be really helpful. So I'm going to click my transect line and click zoom to transect. All right, so you don't only want to use qProfile for geology. It has that, it's great. But if you just need to have a elevation profile, or you want to see information of what your DEM looks like across a certain line, you can come in here and use this topography area and just pull profiles really quickly and see what things look like. So the first thing to do is to click on what DEM should this plugin look like. So I only have one in here, but it is going to show me other rasters that might be present. So I'm going to click on that, click OK, and it's in there now. And one of the default thing is, oh, there's a digitized line. I'm going to click on that and it says, oh, you can digitize a line on the map. And I'm just going to draw one. And if I end it with a right click, then there it is. If I want to digitize a different line, and I can actually do my profile across a really weird path, and it will take that too. That doesn't make a lot of sense for cross sections, but it's great if you're just trying to figure out what's the elevation profile of a hike that you're going on, and you can kind of trace the trail and get that. So when I have that digitized line, then the next thing I'm going to do is click read source data, data profile read. Okay, so it's got that. Then I'm going to go down to calculate profile statistics. And here it's reading across that DEM and picking out all of that information and entering it. So it's just showing me what the numbers are. And then I'll click create topographic profile. And it's going to ask me, do you want to have any vertical exaggeration, things like that? Do I want to flip the x-axis direction or not? So you noticed I drew from west to east or all over the place. But if I want to have it go back the other way, where I want to show my profile as if I'm looking from the north instead, I can do this flip axis. So I'm going to take the vertical exaggeration off and just click OK. And so this crazy profile of elevation right here has to do with that crazy line that I drew on there. And yeah, that's my elevation. But I'm going to have us look at this transect. So instead of doing a digitized line, I'm going to pick line layer this time. And here it will say, pick a line layer. And I have different options, and I'm going to pick my Transect NCAR trail. Now you'll notice, you know, before I continue doing this, I want to get rid of this thing up here. So what I'm going to do is I'm going to exit qProf and then come back in. But so this is just making temporary files, and you'll notice up here, there's an export button, and I can click export figure. And then that profile I just showed you, I can make that go to a file. But if I leave here right now, all of that goes away. So that's something to keep in mind when you're doing that. This is temporary data. So when I come back now, my digitized line is gone. If I try to read my source data, it says there's no input DEM definition. So I'd need to go back and make sure I have my DEM selected. I'm going to do my line layer, pick my transect for NCAR, click OK, read my source data. Now it's happy, yay, because it had a DEM to look at. And just for a reminder of what that DEM looks like, this is that data layer that we're working with, but we're not using it for cartography. We're just using it for pulling information. So I want to calculate my profile statistics. And now create the actual profile. Now I'm not going to click flip access direction because I want my my high part of my profile to be in the west this time. I'm still going to take off the vertical exaggeration because I can kind of stretch out my figure and adjust that later if I'd like. So I'm going to click OK. And this is what my profile looks like across that transect line. Now I can grab this and sort of stretch it out and make it a little bit easier for interpreting geology on top of it. So I kind of want to leave my default information and not have vertical exaggeration and just do it this way later. All right, so that's adding in the profile parts, but now we're going to actually go to the geology and add some of the bits there. Just kind of checking the chat really quick to see if there's anything that I'm really losing people on. Okay, Patrick's on it. Thank you, Patrick. All right, so now I still have that profile here in my memory, but now I'm going to put geology on that same profile. I'm going to pin to it. So there are 4 different things here, and you'll notice the menu is kind of has these little lines that break, and you can pick on different ones to do the particular one you're looking at. So we're going to look at project geologic attitudes first. And this has to do with those superficial measurements, or that strike dip piece. So I am going to choose my strike dip measures as my input for this. Now this is really important because if you don't do this right, then the information that gets transferred to your profile won't be that helpful. There is a thing called the right-hand rule in geology that if I go back to my dip strike little thing here, if I hold my hand and I point my fingers down the hill in the direction that the dip is, using my right hand, then my thumb is going to be pointing this to the strike direction. So on this figure, the strike direction is going to be west. So if you imagine like kind of holding your right hand up there and having your fingers pointing down, then the strike direction is west. And that's a certain convention in the USGS about how strike directions are recorded. So I want to make sure that that right-hand rule button is clicked. And I'm going to change my dip to my dip field and make sure that all of this is kind of set. I'm going to leave nearest intersection. And this is just kind of taking where this dip measurement might be and just drawing a perpendicular line and drawing it straight to my transect. I can label it. I can turn these on or not. If I click this on, then these numbers of the dip and azimuth information are going to come through. So now if I click plot, I get that same profile, but now I actually have these little lines that are showing me what those dip angles for those beds look like underneath the ground. And I have my dip angle numbers associated there. If I take this off and click plot, then I'll just get those same symbols without the numbers. You may choose to do that because if you can remember the numbers or you just want to look back, then this makes it simpler to export into Inkscape, because what we're doing here is building some information that we will then save as a file as an SVG that we can then do more particular drawings on in Inkscape to build our cross section. All right, so we have our strike dip measurements. Now, this project geological traces, we're not going to use because we're not working with that kind of data of different kinds of folds and synclines and things like that. So we're going to skip that one. But we do want to know where these faults are crossing our transect, because that's very important in interpreting our geology about how to draw or interpret our cross section on the side. So I want to make sure that our faults from that Kellogg geologic map that I hand traced are going to be part of this. And they're black. Black is a nice color to use for this. So I'm just going to pick my 0000. And if I want to label it, there are some labels. We only have 2 faults crossing this, but I can go ahead and put that on there. This is labeled as just fault, but it's actually the Boulder fault, and this is called the Maxwell fault. Now, when I click intersect, then I will get that trace put on my profile so that I know exactly where that fault is going to be coming across it on the surface when I'm doing this. This doesn't tell me what the fault looks like underground. It's just showing me where the fault is going across my transect. So that takes a lot more data and knowledge to really figure out that bit. But so we're just going to do a simplification of it with a vertical fault in that space. Okay, and then the last thing, and most importantly, is intersecting our polygon layer with our profile line. Now, this interface is pretty simple. We only have 1 polygon layer loaded into our project, so it's easy to choose, but you need to make sure that you get the right one. And the classification field, again, I'm going to use labels so that I can match these weird little YG symbols to match up with our cross section to our geologic map. Now, when I click intersect, this plugin, as far as I know, does not have a way to load those that geologic style sheet that we had. So this is a little bit kind of hands-on, but you are allowed to change the color of all of these, but it takes a little bit of work. So you might notice that the default that it picked for this area, the Boulder Creek granodiorite, is this sort of moss green. But if we look at our geologic map, it is definitely not moss green. So I can go up here and I can do pick color, and it's going to give me an eyedropper tool. And I might want to make sure that I turn my contours off to do this a little bit more easily, but I can just pick and have it just populate up there. Now, I did this on a Mac as well, and I noticed that this particular function does not work that well, because when you do pick color and you're hovering around, your eyedropper tool isn't activated when it's over the map. But I found that if you're on a Mac and you hover over a certain bit and you hit the space bar, that does the same thing. So if you're doing this workshop on a Mac and you want to adjust your colors, try that, because I think this might, what I'm doing right now and what you're seeing won't work for you. So you'll go into each one of these and change them to make sure. Let's see, where's my KP? And we'll give everybody some time to do this. While I'm doing this. I sort of know where these are, so it's taking me a quicker time to be able to find them. But I know you are probably trying to figure out where the heck is that polygon on my map. Make sure that your labels are turned on so that you can see what you're working with. And then also that you're zoomed in enough that you've got a pretty good chance to get your eyedropper tool on that polygon. All right, so in going through that, I just something to talk about. I've noticed that, and you may have noticed that this KPH layer out here, which is a Pierre Shale sandstone, has exactly the same color as this band right through here, because this is a lion sandstone. So there are actually two different formations, and you can tell that by the labeling, but they're both sandstones. And just because there wasn't something that felt particularly distinguishing about like kind of a shaly sandstone, mostly sandstone, we went ahead and left this as sandstone out here. So just be aware that those two are the same color, but that was just a decision that Patrick and I made when we were kind of going through that style sheet and loading on things based on what we knew about what the formations themselves are. So now when I click OK, and remember this dialog box is part of the qProfile plugin. And I am just telling it what my colors are, and I had clicked intersect. And now when I click OK, it's going to give me that profile with all sorts of stuff stuck on it. So it's this lovely, messy bit of a profile with the surface exposures of all of our outcrops color-coded onto our cross-section, our nascent cross-section. We have some work to do here. But what's great is we have all of this information pinned to it in space, what our dip angles are, where that fault line actually crosses over. There are some little labels that have been stuffed in here that kind of say, this is where the start of the fountain formation is. And you can kind of see that that's where the height of, it's a place called Green Mountain is. That's a different piece. Oddly, this part right here is where the flat irons actually are, a little bit further to the north. If we look at our geologic map, you'll notice that our transect goes right through a valley. So you're not actually seeing that that elevation of the flat irons pop up in there. But if you go right across Dinosaur Mountain here, then you'll see that in the elevation profile. So wherever you pick to create your profile is up to you. If you want to go ahead and work on this more later. I just picked this transect because it had a lot of these dip and strike measurements right on it. And so it's a lot easier to see it in that space. So now before I leave qProfile, because if I do, I will lose everything that we just did. I'm going to go to export and click on export figure. And you can adjust these, you know, its margins and how big you want it to be. I am just going to leave things on default. But the one thing that's a little tricky here is that we don't have a little 3-button bit here. So putting in a full path name of where you want your actual file to end up is a good idea. So if I am opening up one of my File Explorer windows and I want to put it in here, I've already done this a little bit. I called one my messy profile because it's got all sorts of stuff on it. But I can go in here and say, this is the path name. So if I click up on this box, then I can get a blue highlighted path name and copy it. Come back over here, right click and paste. And then give it a name. And also type in the ending of the kind of file that you want it to be. So we want to get a scalar vector graphics file so that we can work with it in Inkscape. You can also just export a PDF if you have a picture of your profile that's all you want for your elevation from your trail hike or whatever it might be. But just make sure that you've got a full pathway name here. If you don't, then your file is just going to land in the applications folder where your QGIS is, and it will be a little hard to find. So for people that are on Macs, copying the file pathway is a little bit more difficult. But when you open up a window, a Finder window, and you right click on a file, go ahead and do that and you'll see something that says copy. You can copy this file. But then if you, while that window is open, if you hold down the Alt button or you, the Alt or Option button and hold it down, you will see that change to copy path name. So then you can get that path copy to your clipboard and then put it in here. So I'm going to click OK. And then my workshop profile SVG that I just created is going to show up in that folder. All right, we're going to take another break in just a short moment, but just wondering if anybody has any questions. All right, I'm happy to talk to people over email after this workshop as well too, but let's go ahead and take a break, stretch. Sitting in a chair is not very fun for this long of a time at a stretch. And so we're gonna, let's come back at a couple of minutes before 10 o'clock. So say 9:57. Just give you a bit of a longer break right now in case you need to let your dog outside or feed your parrot. I have a parrot next door to me who's I can hear out my window right now. So, all right. All right. Welcome back. I hope everybody got a drink of water, reheated their coffee, grabbed a beer, whatever time zone you're in. So one thing I wanted to talk about a little bit, just because I kind of skipped over it, is just having a little bit of a visual of where we were when we were doing all of this. So I put in 2 photos in the markdown record that you all have in the tutorial. And there is one bit of data that we never turned on because I just put it in there for fun. I'm scrolling down all the way to here we are. Here are the photos. So there is one bit of data that we didn't turn on, and really all they were is just for your reference, locations of where these 2 photos were taken. And this first photo is showing the Dakota Formation and what those sedimentary beds look like on the ground. And this is a structural geologist's dream. It's just a very easy thing to walk up to this and put their Brunton compass on the surface of this rock and take that dip angle, and also the strike angle as well. Brunton compasses are built in a specific way to do that easily. And the second picture is on a place where you can kind of see a contact between a more reddish soil and a whiter soil coming together. And that is the contact of the Morrison and Lichens Formation, looking a little to the northwest to see the Flatirons themselves. And you can kind of see those 2 different chunks of the Fountain Formation out in the distance. So if we look at our map and I turn on where those photo locations are, that little gray piece right there is not very bright, so I'll just make them red really fast. That's where those 2 pictures were taken. So that's what that data layer is. And it's always good with geology to go back and forth to seeing what rock samples are, where did this rock sample come from. So I just added that in for some context. So the next thing that we're going to do is take our transect that we've created and this file in the profile plugin, and we've exported it and saved it as our SVG image. And so now we're going to go into a different software called Inkscape and work on how we would start to draw this. And you can see me flounder around a bit in here because Inkscape is not something I use all the time, but it's a really great free and open source vector graphics product that you can use for putting extra touches on any map that you have or doing this cross section that we're going to try. So instead of sharing my screen, I am going to share just directly with my Inkscape now. So I'm going to switch because the functionality of it was a little strange. So I'm going to do a new share. And just open up my Inkscape directly. Hopefully that is, that's working for everybody. Okay, so you can either go directly to your SVG file that you created and click it and do right click and do open with Inkscape, or you can come into Inkscape and save file, open and navigate to that workshop profile that you've created. I have a different one here that I've already brought into layers, and I'll show you why, but right now I'm going to open up this one. Actually, Patrick put it into layers for me, so just to be completely fair. Thank you, Patrick. So when you first open this figure that's been exported from the profile plugin, then you get all of those things brought over. But it's all kind of jumbled, it's a mess, and this is what we want to clean up, as well as use this information to try and build our cross section. So when I'm here and I want to select things, I'm on my default marker pointer here. If I select things, I'll see it like it's actually just one object. And that's not very useful for me. It's great, like when I'm trying to move it around, that I don't mess things up, but I can't edit anything very well. So I need to go up to Object and click Ungroup to be able to separate out these pieces. But it's still just kind of two different things. I can still grab this one thing and move it around. So what I need to do is ungroup twice. And now I have a whole mess of scariness that when I click in there, it's going to be hard to get the right thing unless I've zoomed into something. But it's really nice because I can go in just to this little section and then up on my menus for view, there's also some quick buttons for this that are different on here than my Mac. So I'm just going to use this drop down, but there's a zoom to selection option. And then you can zoom out a little bit too if you're a little bit too close, but you can come in here and move things around and still see that the full profile line underneath that you can use for reference. And then you can come back and zoom out to the whole drawing as well. So the way to work in Inkscape, the best way to kind of keep your brain sorted and not go crazy, is to have this layers panel open. If yours isn't open already, you can click on layers up here and open the panel on this side. And you'll notice I don't have any layers whatsoever. I've just imported one, but I can click on this and I can say, yeah, I want to have a layer that's maybe just my fault markings or my strike and dip. And I can add another layer that maybe just has the outcrop exposure. Or those lines, something like that, outcrop lines. And then what you'll want to do is select these. And if you hold down the Shift button, you can select more than once and put them into these different layers so that you have, you can turn the layers on and off all at once, because you'll notice over here, there are little eyeballs that turn things on and off, and then you can have a better look at what you're working with. So for the sake of time, as I said, Patrick went ahead and created one of these for me. So I'm going to open that NCAR cross trails cross section with layers already built into it. Close this one. And I think I need to resave my screen to make sure that, yep. Let me go back into my new Inkscape. So my layers panel over here has already been built, but you can't see anything right now because everything's off. But if I turn on my lines layer, then I can see just those pieces that have been taken from that intersect with the polygon. So I can see where my outcrop exposures are. And I'm going to zoom to my drawing so it's a little bit bigger. And I can turn on my strike and dip information. I have my text in a different layer. So if I just want to see what that is, I can go there and look at that, or if I want to use it for my labels later on. But right now, mostly what we're going to do is look at our strike and faults, and then figure out what our next thing that we need to do to start building this. And I know right now you're not going to have time to put all of these things into layers. So go ahead and do what you can when you're clicking on the unlayered pieces, but I just wanted to show you how to do that. And we're just gonna get started here about how to go ahead and draw these cross sections. So you might, you'll have your grid on, which is kind of a nice thing for reference, just having everything there. If you didn't export the text labels, then you don't have that cluttering up your space, and it might look a little bit more like this. So the first thing that we want to do is think about our geology. What does all of this mean? The most important thing to look at first are these fault lines. So this is where the fault traces are going across our surface area. And so I know, like, this is the Maxwell fault over here. I don't have a lot of information yet in my mind about what that faults aspect is underground. So I might be able to change that or think about that later if I look a little bit more closely. So I'm really just going to draw a straight line. So I'm going to pick this tool over here that helps you draw straight lines and Bezier curves. And you'll notice that when I hover over this, it kind of, does a little bit of snapping to things that are already there, which is great. And I'm just going to draw a straight line like this. If I actually know that this fault has more of an angle like this, it's more of a thrust fault. So if you want to draw it that way, you're welcome to. Or I'll just go ahead and do that. But if we don't know or have this information, we can try and interpret it. I would just draw a straight line down and say, there's a fault here. And while I'm doing this, I would want to make sure that I am in the correct layer where I want to draw this. So I might want to say, okay, I'm adding new things. And so here, and this you can do, is create a new layer that's editable. And while it's highlighted, that means that's the one that you're drawing in. So I'm going to go ahead and put that on here like this. And we're just gonna, with a small amount of time that we have left, we're just gonna work in this area over here. So then the other thing I'm gonna do is I'm going to look at where these contacts are on the surface between this piece of the boulder granodiorite right here and this piece of the fountain formation that makes up the flat irons. And so I want to draw another line from here that kind of separates these two different beds going down into the earth. And my closest information for that is this dip angle over here that's talking about what the angle of this piece is. So I'm going to go in and just kind of draw a line on top of this and extend it out a little bit so that it's straight. Go back to my cursor and then I can move this so it's dropped down right onto where that intersection is. And then I've started building a guide for how I'm going to draw my polygon or my fill color for the side of this cross section. So I'm going to zoom into this area, zoom to that selection, then zoom out a little bit because that's a little bit overwhelming for me. So there's another really great bit of data with the lion sandstone right here on this side. So I'm going to draw another guideline. And then I'm going to take that and move it so that it's right at that intersection or that contact on the surface. So these are just my, excuse me, let me have a little sip of something. So these are just lines that I can use to then draw a polygon that I can then fill, and it will represent that bit of the fountain formation going down. So I'm going to want to create yet another layer and call this my bedding polygons. Go ahead and lock out my line drawings right now. I was drawing some of my guidelines in my fault lines, but you get the idea. So now I'm in the bedding layer. I'm going to take that same tool and now I'm going to draw a whole outline of this polygon that mirrors what I've got going on in my cross section on the surface. So I'm going to just drop down to this one grid line down at the bottom and use that. Come back up to the top here and close this shape. So now I have something there that with that object, if I go and colorize it exactly the same as it is on the geologic map, then I have filled in part of my cross section. So I'm going to open up the fill and stroke panel. And you'll notice that right now I don't have any paint on this object and it's highlighted. So I know that I'm looking at this one. But I want to have some kind of fill, but not solid black. So here again, I can make use of an eyedropper tool. And I'm going to come in and pick that same color from my outcrop. And I'll want to change my stroke paint to be that same color as well. Always good to hit save on things, which I was not emphasizing during the QGIS part. But now we can come out. And so if I zoom to the full drawing, you can see I've started filling in my cross section a bit here. And because I have these layers and I can turn them on and off, I can see what things look like when I have, let's see, just the parts that I want to end up on my cross section on there. And so there are so many different tools that you can go into Inkscape and do really careful editing. You can move these layer levels up and down so that they appear on top of each other, just the same way that we move our layers in QGIS to have them appear on top of each other or not. So I can move that grid back behind so it's not covering on top of the lines, different things like that. Put my text labels on top, the ones that I decide to keep. Maybe keep those arrows that nicely tell us where the different things start along our profile section, just so that I can have a good place to add my labels. One thing I might want to do is come in here and select this particular arrow since it's kind of off to the side, and do some flipping and move it around so that it's still within my view, and just kind of move things around like that. And then I need to continue building on my interpretation of what my cross section is. And so this is where I would want to go back to my geologic map and get a sense of where this fault is, how it's behaving on things and how to draw things underneath. These parts over here are quite simple because what I would do is continue to take these dip lines that are on the side and draw these sedimentary layers going down. But oh wait, what is this brown stuff? Remember, if we go back and look at our geologic map, we know that that is one of those quaternary pieces that's just sitting on top. So we might want to look to the south or north and look for bed exposures and see how we might want to draw those down underneath. And that's where this data point is coming from, this dip strike that's a little bit further to the south, and that's why it's falling off the line that we see. But we can look at that and say, oh, okay, these sedimentary beds kept going north to south, and I can draw them under this little bit of the sandstone right here. So another thing in looking at the geologic map, you might notice this difference between seeing this gray area up here and this gray area down here. They're the same formation, but they've gotten separated by this pink granodiorite object. And there's a lot more of this over here, along with this also igneous rock that's kind of mixed in there. And there's a fault here. And so if you, let's see, I'm gonna switch back to my Chrome just to give a sense about what this is if we're looking at this map. So our transect goes right across here. Wait, that's great. Hold on, just spastic clicking. There we go. our transect goes right across here. And you'll notice that there's kind of this floaty part of the fountain formation that's gotten broken off from this part over here, and it is separated by that fault. And so that's a really good hint that you have a thrust fault that shifted things. And so being able to draw that onto the map takes a little bit of time to think about it, but how I ended up interpreting that is if we go down to this cross section in progress here, is that you can see that some of this broke up, and it's kind of, I'm just using those same dip angles. But here, that fountain formation is sitting on top of the granodiorite. If you think about the ages of these things and how they get stacked. So from here, I'm moving from an older formation and moving to younger and younger and younger as I go east. So knowing that this sits on top of this, here, I'm very comfortable putting that granodiorite right underneath that fountain formation again, even though I'm not seeing it directly on the surface. If I see it to the north or south, I know it's probably under there as well. And it's kind of mixed in with this other bit of igneous rock. So if this line right here that I drew is not based on any information at all, really, it could be a curved line. You could just draw a dotted line here with a question mark to just let people know that this is a bit of an interpretation. But that's kind of how working with faults and thinking about the ages, the types of rocks that you have, and what their surface exposures look like is kind of that information that you use to go ahead and keep building this construction. So there we have it. I am happy to try and answer a couple of questions in the few minutes that we have left. Look over at the chat. And yeah, I see there's something about the mid-Vatten plugin. I am not familiar with what that is. So that is, that's interesting. That's good to know. I will look in to see what that does. And yeah, some people are having issues loading some plugins, and this workflow is going to be up at that GitHub link for quite some time. So you can go ahead and just work through these steps again when you have everything functional. I probably will take the data down off of the Dropbox eventually, but I'll leave it up for another month at least so people can grab that. I'm happy to try and answer questions about geology as well. So there's also some resources that I put down at the bottom. And if people want to find more information about how to find these geologic maps, going to the National Geologic Map database, there's a whole bunch that are in there that you can, let's see, let's go ahead and pull this back up. You can go in here and search by map catalog and look for geology. They have this map view that needs Adobe Flash Player. So you have to, I think this is going to be deprecated in December. So they are revamping it, which is good. But you can go in here and look for US maps. Look at that amazing color chunk. You can go in here and zoom in to an area of interest that you have And then over on the side, there is a button for list publications in view so that you can see all of the USGS publications that are in that particular area. Another thing that's really great to do is just look for geologic survey of your country or your state and find more information from that as well. These don't always have GIS data. So if you go into the map catalog and you search for things, I'm just gonna pull up the Wells map that we were looking at really fast. Or actually, well, when you go into the search, here we go. You can do it by scale, author, title, and a lot of them are marked if they have GIS data or not, which is really useful. That doesn't always mean it's great GIS data. It just might be a boundary file, but sometimes they have that full polygon layer like the Kellogg map did. So just Googling geologic surveys and GIS data is great. Also in the resources, I have put some links for getting elevation data and also geologic symbology. If you really want to take a dive into this and look at the FGDC standards for it, there are PDFs upon PDFs of very, very specific types of ways to represent folds and overturn folds. And we just looked at the inclined bedding one, but there are a lot of things in here. So I just gave us a small snippet from this full scalar vector graphics library that Dr. Richard Langford created. He went into the USGS and took all of their PDFs and made SVGs, but we're at time. So I think I'm just going to be quiet now. Let me know if you have questions.